Yeah, for our audience, William Falcon is the creator of the popular open source project PyTorch Lightning and recently founded or announced GRID.AI. William created Lightning while doing his PhD at NYU and as a PhD researcher at Facebook AI. Lightning allows users to scale models without the boilerplate, and GRID enables large-scale training on the cloud for these models. Previously, he founded the now acquired NextGen Vest and spent time at Goldman Sachs. And his PhD, which he's currently on leave on to focus on Lightning and GRID, is funded by Google DeepMind and NSF Foundation. His research interest is in unsupervised learning and the intersection of AI and neuroscience. And William is originally native of Venezuela, and he holds a BA from Columbia University in computer science and statistics with a minor in math. So I guess I'll share a screen. Also, if there's some background noise, maybe, yeah, I got rid of it.
Yeah, sorry, I'm in New York City. Yeah, hopefully it helps. But,
exactly.
Okay.
Add some atmosphere. Okay. All right, go ahead.
Okay. Thanks for having me, obviously, and really excited to be here to share with you what we've been working on. So, I guess some of you guys know me and the team from Lightning, and then some of you know us now from GRID.AI as well. So I'm going to kind of walk you through that. And, this is meant to be interactive. So if you guys have questions or thoughts or anything else, please do let me know. So I want to start off by getting everyone to go to platform so that we can all do this together. And we're going to walk through this demo here. So let's just start. Here we are. Can you guys see my screen? Yeah? Okay, cool. Yeah, so I assume you can see my screen because I can't see you guys. Okay, so really what we're focused on is training at scale. And as you all know from doing deep learning and machine learning in the real world, it is not trivial. When your data sets are massive, when you're training on the cloud, when you have cloud resources all over the world, and when your models are huge, right? So that's really what we focus on. And I just want to preface that this is kind of what we've been doing. We live and breathe for the past, I don't know, few years at this point with Lightning, right? So Lightning was born out of training at scale at Facebook AI. So it was, I was doing research there and a few other teams started kind of picking it up, but we were training models, if you view specifically contrastive learning, we were training things on like 500 GPUs model per 500 GPUs, right? And we were doing sweeps. So like we would spin up like dozens of those, each on 500 GPUs. And that was also with mixed precision and a bunch of other tricks to get. And needless to say, things worked. In the beginning, they were a little rough, but now they're very, very solid. And Lightning has been tested and thoroughly used throughout the world. A few thousand companies use those already to do things, training and then putting things into production. Lightning also supports putting things into production as well, but we don't have like a serving engine or anything like that, right? So there are plenty of great tools for that. And so that's kind of what we've been living and breathing. And so you can imagine that at that scale, you run into all of these issues about data, especially when you get into the cloud, even outside of Facebook, right? Once you get outside into AWS or Azure, you're going to run into a lot of these issues. So I just want to direct everyone to here. So if you have a QR code, feel free to go to GRID. You'll get $25 free credit to just try this thing out. So, don't spend it all in one day. But so platform.grid.ai. And you're going to run into the screen here, right? So feel free to sign in with Google or GitHub for, until you verify with a credit card, which you don't have to do today. You'll only be able to use CPUs. So I'm just going to give it a minute so everyone can. And again, this is only if you log in with GitHub. We're not pulling any of your private repos or anything. It's just going to be your public repositories. And once you're there, you're going to kind of screen, right? Mine's a little bit more populated, and this is really the dashboard. And what left is kind of your daily costs, right? So we can give you estimates of how long your jobs are running and how much they're costing. This is running on AWS. And then on the right, if you wanna, we don't have to click now, but if you do want to see this demo, this is a CFAR10 demo. So you just click on that and then it'll start. On the bottom left, you see last runs. So you see, we actually do research here as well. So we've been training a bunch of VAEs and different things for some papers that are coming up. And you can see that, we're using Spot and they've been running some of these models trained for 2 or 3 days, but they're pretty cheap. We can use Spot, and I think we've used V100s pretty much for all of them as well. And then on the right, we have this thing called Sessions, which is basically like interactive notebooks, which I'll share with you in a minute. So go ahead and find code, like just find a GitHub repo that you have, public repo, so that we can try this. And if you don't have one, I put one here. This is from the PyTorch examples, and this is for a DC GAN, right? And this is going to be, so you can scan this QR code. And so just copy paste a string. So basically go to GitHub, find the file that executes the model. So in this case, it would be the main.py, and copy that file. So I'm going to just show you what that looks like. So that is the DC GAN here. Okay. And I just want to show you there's nothing. PyTorch. There are some arguments up here, so we're just going to set a few of them. And GPU, we're going to set data root, and then we're going to set CUDA because, well, actually, you don't have to, right? So you won't need to run this on a GPU here. So we'll turn this off. We'll set that to 0. And so yeah, so now you're on grid. So go back to here. Okay, so now you're going to take that link, and then you're going to, on the top right, there's a button called New, where you can click on that, and it's going to allow you to do 3 things: run, session, or data store. Is how we scale up training, right? So you just stick your code in there, and then we just launch it across all the machines you want, and that you're able to run. And then session is going to spin up an interactive machine that you can debug on, you can SSH into, you can do VS Code, etc. And then data store, you can upload data on the UI or through the CLI if it's a massive data set, obviously. And that's going to be auto-versioned as well. So when you click on new run, you're going to see this here, and you just paste that link and press enter, and that's going to populate. And if you had a data store uploaded, you'd be able to select it here, right? So it doesn't matter how big it is, we'll link it up, and it'll be very fast, so that when the models are running, there won't be a bottleneck, right? So I'm sure if you've tried running anything on the cloud, your bottleneck is most likely not going to be the compute. It's going to be and if probably you're using S3 or something like that, that's going to be very slow, especially at scale. So we spend a lot of time optimizing that funnel so that you don't have to deal with it. And that's the data store. So you link up the data store. In this case, there isn't a data store. And then you can select any kind of compute that you want on here. I would encourage you to use Spot at the top right. Some of your $25. So you just turn that on and then select whatever you want. In this case, just select the 2 CPU one because we don't have GPUs until you verify with your credit card. Otherwise, if you are verified, then you can go ahead and use the GPUs. And then down here, since we're not running with the GPUs, don't pass in any of these flags. So don't pass in CUDA or NGPU. So basically set NGPU to 0. And then the other flag you need to set is data root, right? So let me just show you that real quick. So that's going to be, again, I'm just doing this with you. So I'm going to click new run. I paste this on here. Now I'm going to select, I am verified, so I can run on GPUs, but I'm just going to pick something cheap. I don't want to burn any money. And then the flag I'm going to pass is NGPUs 0 because I guess the PyTorch team set the default to 1, so we want to turn that off. And then the data roots, which is required. In case the model happened to download the data, so I'm just going to put a dot because we're just going to use the working directory. But in normal cases, you wouldn't just download the data because it'd be like 15 terabytes, right? Or something massive. So you would use a data store, you would attach it there. And then if I were to, like, for example, attach ImageNet, I would just copy this little guy here, and then I would just pass in the string there. And then it would automatically link it under the hood, so you don't have to deal with it. So in this case, we will not attach ImageNet because that is going to be a little bit. So you hit that, and then now we're telling you to estimate it, and then you press start the run, right? And that's it. Now you're going to be training cloud instance, and you can see everything's being queued. Once you're on here, you're going to be able to see the artifacts. You're going to be streaming through here. You have all the parameters. you have the logs, right? So we're building all the machines and the infra and all that stuff here. And then once your model starts training, you have the standard out logs, which you can see there. And what's cool about Grid is that everything's fully reproducible. So literally, if I just want to redo this thing, I can just clone that run, and it's there. So it's going to exactly do everything. It has the commits, the hardware, the code, all of it there. It like points to your code, obviously, data. And then you're able to exactly replicate this. Now, if you're at an enterprise, this will be infrastructure or in your own AWS account, which we can still orchestrate. And then at that point, it's all in your infra. So let me go back to this thing here. So hopefully now you guys are seeing this thing run on your accounts. And it'll take a few seconds for things to spin up and then execute and so on. Depending on the instance you choose, and depending how many people are on the platform, if there are a lot of people, like things might take a few minutes. Otherwise, it'll be pretty fast. So obviously, all of this you can do through the CLI as well. It's exactly the same. So you can use, if you have your terminal open right now, just go ahead and type pip install lightning grid, and you're going to make sure you're like in a con environment or something. So you can install that there. And then type in grid login, press enter. That's going to take you to your grid account. And there, I'm not going to share my screen because it has my credentials. You just copy, there's a link there to copy the credentials, paste it back in, press enter, and then Grid will log you in. Once you're successfully logged in, so I'll give you guys a few seconds for that. So once you're successfully logged in, you can go ahead and do exactly the same thing. In this case, I'm just going to clone the repo. So this is a PyTorch examples repo again. And then I'm going to go to the folder that I want to run. So in this case, a DC again. And now just don't press Python main yet, because I want to talk through this for a second. So if you're using Lightning, you know that you can go between your laptop and arbitrary hardware, like GPUs, TPUs, whatever, right? So normally you would run this command this way. I guess potentially this demo repo might support that, but if it was a Lightning model, it would for sure support this. So you'll be able to say Python main.py, and then it would just run locally. Now, all you need to do to run on Grid is change the word Python with grid run on the cloud. So if you just press enter right now, it'll actually run. Well, you need the data root argument as well, right? So don't do that. Now, if you wanted to run on GPUs, for example, obviously you'd have to verify on the platform. But after that, you would pass in the script flag. So, the PyTorch team coded the script flags to enable it to run on GPUs. So you have to pass in the CUDA flag and then the NGPU flag and set it to 2 or 4 or 8, whatever you want. And then you need the data roots flag as well. And then you choose the hardware that you want to run on, right? So you can say instance type, and then in this case, we can pick 2 V100s with 16 gigs of memory. So each V100 will have 16 gigs. And then Grid lets you actually, so I don't want to share. Instead, I want to say, hey, give me all of the compute on that machine, right? Otherwise, I could run this script twice, and each one would run on one GPU independently on the same machine. So you'd only pay for one instance, which is pretty cool. And so in this case, I'm going to run this model on 2 GPUs.
Really cool.
Because once you start using this with something like Lightning, you can actually start running at scale. Now, you can do it yourself, but you're going to have to code up all the distributed. Make sure your model works for distributed. Grid will set up the infrastructure correctly. So as long as your model can do the distributed, you're fine. And this applies to PyTorch, Keras, TensorFlow, etc. But if you're running, you don't have to do anything. You just change that number to 32 GPUs, and you're good to go. And then we're going to do multi-node and all that stuff and just set it up for you. And link the data, make sure there are no bottlenecks, and so let you train at scale. Now, we have parameter sweeps, which means that, let's say that this main.py took an argument, right? If it was like learning rates, I could basically say something like, let's see here. So I could say something like, if I had this script, let's say, grid run main.py, and I had like learning rate, for example, it'd be something like this normally. On Grid, you can literally just pass in a list, right? So I can say something like this, and it'll run, in this case, 3 models, one of which is learning rate. You can also use distributions, right? So I could sample learning rates. In this case, I could sample 10, right? And so I'll get 10 models running at the same time. And I can do combinations, right? So if I have different backbones, for example, I could do something like run on, use the ResNet 18, and then use the ResNet 50 backbone, and so on. And so now I'm going to get 20 models spinning up, right? So you can see the power now. So I'm spinning up 20 different models at the same time. I literally haven't touched the code, right? This is not even my code. This is PyTorch code. And then I can set how many GPUs I want, and I can just kind of arbitrarily spin up this hardware. And that, again, it's all completely, you can see how we do that under the hood. But at the end of the day, you don't have to deal with any of this. You can just focus on training models, which is the goal, right? So everything we do is about making sure that you don't have to deal with any of the engineering. So let's talk about Lightning for a second. And if you haven't used it yet, go try it out. It's the way I describe it is basically organized PyTorch. And I'm comparing it with, Hadoop is just another it's a popular GitHub project. It has nothing to do with us. It's a distributed job execution. But I just want to show the velocity at which Lightning is moving, right? So this has only been out, I don't know, a few years at this point, but it's already surpassed projects that have been around for a very long time. So it's got massive community adoption, very, very fast adoption. And again, this is being used at major companies, biggest companies in the world. And I can guarantee that the stuff works at scale because we work closely with those companies as well. And we have over 480 contributors. And these people are, PhDs. They're the top research engineers. They're the deep learning engineers, machine learning engineers from across the world who are contributing their code and their know-how to GRID, to Lightning, right? And so you're getting all of this expertise that would take a lot of time to build. So Lightning is going to be extremely optimized to work at scale and also for production. I want to talk to you a little bit about infrastructure, right? So this is obviously MLOps, and I think I want to tell you a little story. And over the COVID, few months, I guess, that we were all hiding at home. I was in Mexico. I'm from Latin Mexico, and there was a street right in front of where I was staying, and it just got me thinking about something, right? And the street is pretty old; it's a few hundred years old. And if you see in the middle, there are like these tracks, and these are like carriage tracks. Basically, it just dawned on me that if you started with something like a carriage, and you just invented this today, that you would have to build this infrastructure to make this thing work, because it's not going to scale when it starts raining and so you have to develop all of this stuff, right? And you have to develop roads. And we're seeing that today with electric cars, right? So companies like Tesla, they're making incredible machines, but they're limited by the infrastructure because the cars can only have so much range. And, fast forward a bunch of years, this massive system that supports all of these new technologies. And so what's cool is if you think about if you think about electricity as well, it's kind of the same story, right? So we invent this ability to have power delivered to your house, except that people don't light bulbs, right? And so you have to figure out how to develop the power grid to be able to develop that. And what's really cool is that, I guess the first power grid was, a few blocks from here, which is downtown Manhattan. And it's really interesting how there was so much research into getting that to work. And it's not just us, right? So there are dozens and hundreds of machines at this conference that are all doing incredible work to get this to happen, because it's a really hard problem. Like, we're definitely not going to solve it alone. And I think that collaboratively, right? And so if you think about AI and deep learning and how that's scaling, it's going to take a massive community effort to make that happen. And to make that kind of like a worldwide thing, right? And so really, I think for AI, there are many things that you have to do for productionizing models, which, we don't cover in GRID, and there are many, many tools that can do that really well. What we focus on is the training side, right? And I think I do that because there are a lot of problems, and not all the problems, but there are a lot of problems where there are just unknown models, right? Or there are just unknown data sets, and you have no idea what's going to work or not, right? You can start with some sort of baseline, but then you're normally going to have to build up on that to be able to deliver any kind of value. So, and the ability for you to get through that is just how fast you can move through it. And that process normally works like this, where you start with an idea, and then you kind of tweak that idea a little bit, and you spawn off a few more, and then something kind of works, and you continue, and so you branch. But this happens sequentially today, right? Because we don't have the ability to scale up like this. So this is a lot of what I've been focused on, basically since I started my PhD, is how to iterate through ideas quickly. And that was a lot of the motivation for Lightning and Grid as well. So the whole point is to make this happen in a few days. Now, in terms of Grid, we have 3 tiers. Community tier is what you guys are using today. And there you're going to be able to access most of the features. You're going to be able to train things at scale and all that. And then on Teams and Enterprise, you're going to get all those like collaboration features and then the ability to, work on private clouds and so on. And, there are many, many other features that enterprises and teams need at scale. And you're obviously free to try the whole product on Community. We have an active Slack, so go to the website and you can actually join it there. So let me just walk you through that right now. And you're going to be able to ask us questions there and be able to work with us. If you're a user of Lightning, that we're very fast and very responsive. But if you just go to the website, you're going to be able to see here the community, right? So you can click on that, join our Slack, and just chat with us, right? Just a lot of people who care about doing really good work and want to be able to scale up. So that's kind of what I have right now, and I just kind of wanted to open it up for questions as well, and like just have a kind of interactive session.
Sure. Well, thank you for the excellent presentation and kind of going over all the features of PyTorch Lightning and Grid.AI. I guess in terms of your development process for Grid.AI, because you kind of took it from originally like an open source project, which was like PyTorch Lightning, which the community contributed to, and that's kind of now transitioned to the kind of infrastructure around that would allow people to kind of like the actual hardware to be able to run models at scale. So how did you kind of transition from something that was open source into more kind of into a kind of a company or a startup? Like, what was that the original intent, or is this something that kind of developed over time?
I mean, my original intent was to build a little, piece of code so I could do my PhD faster, right? And then I think it was just more useful for a lot of people beyond that. So that became Lightning, and then got open source. And then as soon as companies started using it, then, there was like a very, very clear need to be able to run the stuff for them. And so that's where Grid was born out of. Now, in terms of our development process, so we're still very open source focused. We will be open sourcing a lot of the Grid stuff as well. We just haven't yet because we need to clean up the code and so on. But we are doing that, right? Today, the only things that are open source are Lightning. If you want to contribute, we have a very, very solid contributor program that you can join as well. And, we help you, and it's a good way to get back to the ecosystem.
Certainly. And would you say, are you targeting researchers more, or companies that are, or like research at companies where they're kind of iterating through different models on their data set? Like what is the core kind of like the target audience here?
Yeah, it's people who are iterating through ideas, right? So there are companies most of the time. Some of them are at research groups, right? So there could be R&D, there could be machine learning engineers, there could be data scientists. I mean, I feel like all of these terms nowadays are like very, very abused. So everyone's working on a little bit of everything. But basically, if you have data and you have some models and you're trying to get value out of that, and maybe the baselines, I mean, you can run baselines as well, but if the baselines are not really iterating through that process, then really that Grid is for you, right? There are a lot of people that are also in academia that use it, right? Because they also need to do a lot of this R&D work. So it's really meant for that, like, you want to find answers, and it's not as simple as like git clone, run this thing, and like, cool, I solved my problem, right? There's a question here about private GitHub repos. Yes, so you can just enable that. So let me just share my screen. I didn't do that here because I want to make sure you guys are aware. How do I share my screen? Yeah, here. So if you go to your settings, you can just enable private GitHub repos there. So down here, settings. And then I believe it's integrations. Yeah, so I have it enabled. So you just click that button, and then it'll give you access to the private repos.
And that's once you're a paid user, or that's beforehand? Like that's kind of like the...
No, that's right now. Like you don't have to be a paid. Yeah.
I see. And why the decision to not kind of also handle the productionizing aspect of things? Is that like, let's say once I've trained, like if I'm at a company, I've done research, I have a model that I validated. I would like to put it into production. I'd like to use the kind of the same environment that I'm doing the training for to, kind of smoothly transition into production. So why is it that's something that's kind of outside the scope of GRID.AI?
So one is, we find a lot of companies already have some sort of systems for that. And so at the end of the day, the model is just a weight, like a file, right? And then you just import some code and run it. And then companies' deployment systems are generally pretty complicated. It's not usually just a simple model. You can just copy the weights and, you're off to the races and do your thing there. We also have an SDK coming up where you can do this, through code. But it is just like a lot of stuff to handle, right? And I think on both sides, I think the research, this part of it, the model iteration and the building of models, is very complicated, and it's already a lot of stuff going on there. So we usually like to focus and make sure we nail things, right? So like Lightning was basically geared for like a year and a half until we were like, okay, this works really, really well. And then we moved into production, and then you can export Onyx and Serve and so on with Lightning now. So I think that what we want to do is just make sure we nail this user experience first, and that we really solve this use case. And then after that, I think it's worthwhile partnering with companies who have really good kind of production systems to be able to have integrations with them as well, so that things can kind of work together.
Right. So I guess in terms of integration, one popular kind of library is Hugging Face, and kind of services Hugging Face. So I get like how does PyTorch Lightning kind of integrate with like Hugging Face if I'm like I want to take a model. A lot of times now the model is available on Hugging Face, something that's kind of just something that's just been published and researched. So can you talk about like is it possible, like what's the integration like with Hugging Face?
Yeah, so we actually have a repo called Lightning Transformers, which is PyTorch Lightning integrated with Hugging Face. So you can go there, and you can literally run and train anything on Hugging Face with Lightning as well. And again, GRID is agnostic, so you can just train Hugging Face models in GRID as well. We're not going to anything like that. So I think that there are kind of tighter integrations that we can do there. But at the moment, it's no harder than what I just showed you.
I see. I guess in terms of kind of scalability with Lightning, like I think you have kind of deep speed integrations, and have you kind of tested like the kind of the limits of how well you can scale kind of models, or like what the largest, the scalability of kind of the system with Lightning and GRID?
Oh yeah. So we, I think it was like a month ago. We, at this point, maybe a little bit more, we published a blog post with Microsoft. So we work very closely with these companies, right? And we scaled up this like GPT, MinGPT to 46 billion parameters, only using 8 A100s. So that's, just to give you context, that's like a third or what OpenAI did with GPT-3 using thousands of machines or whatever it was. So, I mean, a lot of this is obviously because of the deep speed work, but Lightning integrates really easily to the point where if you just want to use deep speed, it's literally, you would have, let me just share my screen just so I can show you what it would look like. You would have some code like this, right? And then you would have like a trainer, and then you would say, something like GPUs equals 8. And then I believe it's like plugins. You'll be able to say like deep speed, just like a string basically, or backend, I think it is. Sorry, it might be accelerated. I think we keep changing this. You just do that, and that's all it takes, right?
Right, yeah.
And then after that, it just kind of scales up.
And do you find that works with every model kind of out of the box, or sometimes there's like in terms of like the user experience, once like someone is trying to use this, do you find that there's a lot of debugging that happens that has to happen for it to work, or is it?
There are sometimes you have to debug, but generally we don't find that with this kind of stuff. So like the debugging usually happens when you're trying to run your model for the first time. Like generally you want to get your model running first. Once that trains, then the other stuff's going to work, whether it's 1 GPU, 10 GPUs, 32, whatever, all of that's kind of work, because the way that we do CI testing under the hood is we test all of these combinations all the time. So as long as you're compliant with the framework, then you're good to go. But if you look at the Lightning repo today, you see that we run thousands of tests, and those tests run on every single PR across CPUs, GPUs, TPUs, multiple TPUs, multiple GPUs, multiple nodes, and like it's at scale that we're doing the CI/CD as well.
Right. So it's kind of like, and you test against frameworks and models within those frameworks.
We'll train models to certain convergences to make sure that like we get exactly whatever we're expecting. And we also test against the version, that same model, we'll code it up in just plain PyTorch, and we'll test it against it in many other settings to make sure that we get exactly the same loss and accuracy, 5 or 6 decimal points. And then that the speed is, it's like just as good or slightly better usually, so that we make sure we never divert in performance. Right.
Yeah. Well, I mean, in my own personal experience, I've had, it's always been very positive using PyTorch Lightning and kind of in my research. You find what kind of use cases has GRID.AI really served really well so far in terms of kind of your users and industry? Like, what have you seen the biggest kind of successes so far?
Yeah, I mean, I think it's like I don't want to go into too many details about clients because we want to protect their confidentiality, but you tend to see really doing like cutting edge research, like they're like oil and gas, they're retail, they're self-driving car companies, that kind of stuff, where there's not just like for them, they usually have a baseline, but then after that they have to like get really nitty gritty and they have their own data, so things are going to change. So I wouldn't say it's necessarily a particular industry so far. It's more of like the type of user that you are. So if you're really focused on like novel or like trying new things, then this is exactly kind of the platform for you.
I see. And I guess, so where do you see kind of the GRID.AI going for the next, like, let's say in terms of like 1 year, 2 years kind of like horizon in terms of like how it's growing? Yeah. How do you see, like, what's the trajectory that you kind of...
Long-term vision is that the people who are building the models are the people who are kind of doing a lot of that work, that the teams around them are really supporting in special circumstances, not like today they like need them for everything. I'd rather it be where like, they can kind of like very edge cases and that kind of stuff. But at the end of the day, the way I think about putting something into production, it's just like statistically, right? Like when you train your model, you use a training split, you use a validation stop. And then if you're going to publish this, or, hopefully you're using a test set if you're putting it into production as well. Most people don't, but they should.
Right.
But I think there's a fourth split, which is the production system, right? Because you're getting data in there and it's no different. It's just another split where you measure performance, eventually it drifts away, then you need to retrain and so on. And so it's very similar. Sorry, there's like a New York ambulance going by. But yeah, it's a very similar process. And a lot of that like MLOps that has to happen in there, I think that, not just us, but a lot of great companies here are making strides to kind of get rid of a lot of that.
Of course. I guess in terms of your pricing too, like the pricing seems quite reasonable for like the kind of different types of instances. Like if you want interruptible versus not, like how are you, that's usually like the main driver in a lot of cases, right? Is like how are you able to kind of, are you kind of in terms of like getting the amount of hardware, the compute to be able to kind of serve so many people, how are you able to kind of manage that at scale?
Yeah, so we've been working very closely with cloud providers.
I see. Okay.
Yeah, but I mean, look, we're venture funded, right? So we have a lot of advisors that I guess have access to a lot of these resources. So we're able to get really good scaling from that.
I see. Okay. Well, I guess, thank you very much for kind of like the little workshop and presentation. Where can kind of people maybe follow up? I guess they can just kind of go straight to your website and sign up, or?
Yeah, sign up, join us on the Slack and just chat with us, right? We're there. I mean, I'll answer your questions, whatever you want. And then see what you like, and then talk to us if you want to do anything larger than the community. So.
Of course, yeah. Yeah, I mean, a lot of it is community driven anyways, so I guess anyone can join the community and kind of add their own kind of voice to it, right?
Yeah, and by the way, we've only been publicly available for like a month at this point, so please give us feedback, let us know what works, what doesn't work, so that we can continue amazing and help everyone deliver the value that they want to deliver, and stop focusing on so much infrastructure work.
Definitely. Well, that's a huge relief for everyone who's kind of doing that kind of hard grunt work. So yeah, thanks again.
Cool. Thank you.